Hi guys, so today's going to be the first video in a 5-part series on how to solve quadratics. Today we're going to be working with the GCF to accomplish this, and let's get started. So before we work with the GCF, we need to understand one key thing that most people know just automatically, but it's helpful just to know that this exists. It's the zero product property. Zero product property. And it goes like this. It goes like this. If A times B equals 0, then either A equals 0 and or B equals 0. Because the only way to get 0 as a product is to multiply by 0. So A can equal 0, or B can equal 0, or maybe they can both equal 0. And because 0 times 0 will be 0, 0 times anything will be 0. So that is a key thing. It's pretty obvious when you think about it, like why is this a thing? But it's so useful for factoring GCFs. This is how you solve. Okay. So now let's talk about what a quadratic is. Quadratics are polynomials that have one of the variables is raised to the second power, so it's a second degree. They're second degree polynomials is what you call them. Basically it means we have something x or something a, some constant a, and then a variable x squared plus bx plus c. A, b, and c in this case are constants, so they don't change. So say a is 3, b is 2, and c is 1. You get 3x squared plus 2x plus 1. The x value can change, but the a value will never change, the b value will never change, the c value will never change. Only the x value can change. So we're just using a, b, and c as placeholders just to show that these values exist. B can equal 0, or c can equal 0, or both. If b equals 0, then you're just left with ax squared plus c. If b equals 0, and then if c equals 0, you're left with ax squared plus bx. Or they can both equal 0, in which case you're left with ax squared equals whatever, 0. You want to set the equation equal to 0 whenever you do this. So that's just what a quadratic is, real simple. If you want to learn more, you should probably learn more about that if you want to. But that's just the simple explanation that I will be using. A, b, or c can be negative, so you can have minus 2x, like 3x squared minus 2x, minus 1, stuff like that. So, okay, now that we know that, the GCF, as everyone knows, is the greatest common factor. So we will be trying to look for the greatest common factor. Now let's work on a couple things. Okay, so let's talk about what solving a quadratic really means. Solving a quadratic means you're trying to find the solutions of it, which is called the root. So you're trying to find which value of x makes this equation equal 0. So you have your equation ax squared plus bx plus c equals 0. And now you're just trying to find which value of x equals 0. So we'll just use our constants 3, 2, 1 for a, b, and c. 3x squared plus 2x plus 1 equals 0, right? So now we need to know which value of x will make this equation true. So that's what we're working on. That's what solving a quadratic is. Those values of x, which there are several, mainly 2. There's either going to be 2, 1, or it's not possible to solve. But we'll talk about that later. So right here, we keep your mind open to have multiple solutions. Okay. So that's it. We're trying to find the roots of a quadratic, also known as the solutions. So it's also called the zeros of the quadratic because it makes the equation equal to 0. So now let's work on some factoring. We'll start with a simple one. Let's do 6x squared minus 15x equals 0. Now we're trying to solve this equation, but the first thing whenever you're solving a quadratic that should come in your mind is this quadratic, does every single term in this quadratic have a factor? common factor, the greatest common factor. So right here we have 6x squared and 15x. The negative doesn't really matter at this point, unless both were negative, then you can factor out with the negative. So we will do 6x squared and 15x, and then this is 2 times 3x squared, which is 3 times x squared, which is obviously x times x. And this is 3 times 5x, which is 5 times x. Now, I don't expect anyone to actually go through this process, this factor tree, over and over again. If you look at a problem like this, you can probably see right away, oh, 3x, we see that. But for now, since we're just starting, we're going to work like this. So now let's write out the prime factorization. 2 times 3 times x squared, and then 3 times 5 times x squared. Or actually, let's do it like this. This is easier. And then we can do our normal factoring way where we can be like, hey, they have 3x in common. Oh, this is not x squared. Sorry. They have 3 and x in common, and they have 3 and x in common. So their common factor is 3x. So now what we do, we take out 3x from this. Using the distributive property, if we take out 3x, so what's 6x squared divided by 3x? It's 2x. So you get 2x minus, and then what's 15x minus, or negative 15x divided by 3x? It's negative 5. So we have 2x minus, this is our negative, and then 5. Boom, that's simple. And then we have that equals 0. So now this is where a zero product property comes into play. If AB equals 0, then A equals 0 and or B equals 0. And so these both have the variable x in it. So there are no constants. Both of these terms can change. Here, I'll just put this in parentheses to make this easier. Both of these groups, this parentheses group and this parentheses group, both can change because the x value can change. So we need to set them both equal to 0 to try to use this property. So 3x equals 0 and 2x minus 5 equals 0. Well, 3x equals 0, divide by 3, you get x equals 0. That's simple. We can use the zero product property again. And so x equals 0 is one of the solutions here. The other solution, 2x minus 5 equals 0. So 2x equals 5, and then x equals 5 halves. There is your second solution. So now we have both solutions of this equation, x equals 0 and x equals 5 halves. So usually people write it like x equals 0, comma 5 halves. I would keep it as a improper fraction. I would not do mixed numbers at this point because it becomes helpful later on to keep it as improper. And then, or you can write and then just circle this entire thing or something. That's your choice. That's completely up to you. But this is how you factor using the greatest common factor to solve a quadratic. We can do one more. We'll do 2 more examples. Actually, let's just do one more example. 2x squared plus 8x equals 0. Now at this point we have 2x. Do we know 2 goes into 8 and 2? But wait, these variables, they both have x in them. So we can take out 2x as a whole. 2x equals 2x squared minus 2x, or divided by 2x is x, plus 4, because 2x times 4 equals 8x. Now when you do this, you might just want to go ahead and check real quick mentally, like, does this equal this and does this equal that? So 2x times x equals x squared, 2x times 4 equals 8x. Okay, good, we got that. Equals 0. Now we do the zero product property again. We set, I'll put this in parentheses to make it easier. We'll set both these parentheses equal to 0. 2x equals 0, x plus 4 equals 0. Well, now we have divide by 2, obviously x equals 0, we found that again. And then x equals negative 4, subtract 4. So then I like to write mine with the comma. That's just me. And then, so you have that, and this is your final solution. Some arrows. And yeah, so it's really simple to do it with greatest common factor, but most quadratics will not be this simple. So they, like, in these 2 quadratics, c is equal to 0, so it's really easy for us. But let's do another one. I lied when I said only one example. 3x squared plus 6x plus 12. Let's take out 3, because that's the only thing that goes into, I forgot to set to 0. The only thing that equals these is 3, right? So we'll just take out 3. That's the only thing that can do it, because x won't go. So 3 equals x squared plus 2x plus 4. Yep, we multiply these out, we get the same thing, and then equals 0. And at this point, if you want to keep the 3, if you're doing homework or something and your teacher wants you to keep this factored, they want you to show the final factored form, keep the 3. But if you're just trying to solve this, there is no real need to keep the 3 because you can just divide by 3 on both sides and then this will go away and this will stay 0. But that's totally up to you. But now look, we can't set both sides to equal to 0 because guess what? 3 will not equal 0. So we can't use the zero product property on this. 3 is not equal to 0. This is a constant. This will not change. This will never be equal to 0. So that means this must be equal to 0, which is why I'm saying you don't need the 3. I'm just going to take it out here and keep this as 0. Now we need to solve this. But this won't be factored. We can't factor this and solve it because the c is equal to something. So at this point, we will have to use one of the other techniques that I will show you in the next 4 videos to try to solve a quadratic, the rest of the quadratic like this. So that's it for this time. If you have any questions, just comment down below. And yeah, next time we'll do part 2, square roots.